The first question here says a curve is given by the parametric equations x equals 2t and y equals t squared minus 4. Find the coordinates of the points where the curve meets the x-axis. So it meets the x-axis when y equals 0. So it always crosses x when y equals 0. So let's make y equal to 0. So 0 equals t squared minus 4. So t can be plus 4 to both sides, square root both sides. So t can be plus or minus 2. So what are the coordinates? We have to substitute our t values into our x and y to find the coordinates. So when t is negative 2, two negative 2's are negative 4. And when t is negative 2, y will be 0 because it crosses the x-axis. And when t is 2, x is 4, and we know y is 0. So we have these 2 points where it crosses the x-axis. One for you to try. Give it a go. So again, it crosses x when y equals 0. Let's make y equal to 0. So we've got t minus 2 times t plus 1 equals 0. So what makes this 0? T can be 2 or t can be negative 1. When t is 2, 5 minus 2 is 3. And when t is negative 1, 5 minus 1 is 6. So it crosses the x-axis at 3, 0 and 6, 0. A curve is given by the parametric equations x equals t squared minus t minus 6 and y is 2t minus 4. Find the coordinates of the points where it meets the y-axis. So it crosses y when x equals 0. So this time we need to make x equal to 0. So 0 equals t squared minus t minus 6. We could use a calculator, but I'll just factorize this. So it is negative 3 plus 2. So t is 3 and t is negative 2. So it crosses y when x is 0. So we have 0 when t is 3, y is 2 3's, 6 take away 4, 2. And when t is negative 2, we get negative 4 take away 4, which is negative 8. One for you to try. Give it a go. So again, crosses y when x equals 0. So that's when t is 0 and when t is negative 1. So we're going to have 0, substituting in 0 to y, we get negative 5. And substituting negative 1, we get negative 7. Find the points of intersection of the line 4x plus 3y minus 2 equals 0 and the curve given by the parametric equations x equals t squared and y equals 2t. So we need to solve the simultaneous equations. So we can substitute our x and y in to our first equation and we'll only have something left in terms of t. So 4x, so 4t squared, plus 3y, 3 times 2t, minus 2 equals 0. So we've got 4t squared, plus 6t minus 2 equals 0. That's half everything. And then I don't think this one is going to factorize. So let's type it into the calculator. So polynomial degree 2, 2, 3, -1. So we have t equals -3 plus root 17 over 4. I'll store that as a. Or -3 minus root 17 over 4. So to find the coordinates, we need to substitute these in for x into our x and y. So x is t squared. So we have a squared, which is 0.079. And y is 2t, so 2a is 0.56. Second one, so we want -3 minus root 17 over 4 squared for x, which is 3.17. And 2b, which is -3.56. So they are the 2 points of intersection. One for you to try. Pause the video and give it a go. So we have a line y equals 2x minus 4 and a curve given by the parametric equations x equals t squared and y equals 2t. So let's substitute these in, our x and our y. So we've just got something in terms of t. So we're going to change y into 2t. We're going to change x into t squared. So that gives us 2t squared. We take 2t away from both sides. 2t squared minus 2t minus 4 equals 0. Let's half it, and this one will factorize. So we have -2 and +1. So t is 2, or t is -1. So when t is 2, we're going to get x is 2 squared, which is 4. And y is 2 2's, which is 4 as well. When t is -1, x is t squared. -1 squared is 1. And y is 2 -1's, which is -2.